Okay guys, in digital tech, you have been learning all about wearable tech and upcycling and all of these different ways that I can take a basic garment and turn it into something more. Now, the digital tech element of wearable tech is a really interesting field. Most of the time you guys were looking at examples like, smartwatches or, the Levi jackets that you can turn into wearable tech. The tech part of those garments is what we're going to look at today. So the tech part, at its most basics, what you usually have on these garments is an electronic circuit board. So what we're going to look at today is we're going to get to know to understand how an electronic circuit board works. That's why we're learning this. So how do you know if you've got it? Well, you should be able to identify the different parts of an electronic circuit board, and you should be able to explain the relationships between the different parts by the end. Okay, so digital tech, wearable tech. The digital side of the wearable tech is circuit boards at its most basics. So let's go. These are 3 different examples of circuit boards. What we're going to do today, some are more complex than others, obviously. What we are going to do today is make really clear what the different parts on these circuit boards are and how all those parts are related. So when you're looking at a smartwatch, for example, how a smartwatch works is it has a really small little circuit board inside it. Something that's not too dissimilar to the microbit that we'll be using. If you look at a computer, it has a way more complex circuit board, but all the same principles apply. So something like this is a gaming circuit board, or what goes inside a computer to make it work. This is a really complex circuit board, but again, like the more basic ones, all the same principles apply. This is a little bit more of a simplified circuit board that goes in the back of a gaming console, a handheld gaming console. So a little bit similar, but all these 3 circuit boards have a few things in common. The things that they have in common are the different basic parts that make up them. So an electronic circuit, let's go for a definition. An electronic circuit is a device which is made up of resistors, transistors, capacitors, and switches. They're the 1, 2, 3, 4 key parts, and they're all connected by wires or traces. Now, when we're talking about how stuff actually gets around a circuit, we're going to use the word current. So electricity flows around between all these different parts in a current. As this electricity flows between the different parts, what you're able to do with a circuit board is solve, simple and complex problems. So you can actually start solving problems with these circuit boards, because what you're able to do with this current by moving it from one place to another is actually take data from one place to another. So like I was saying before, the 3 very different circuit boards, every piece of technology, from computers to phones to smartwatches, are made up of electronic circuits. So every piece of technology is essentially made up of electronic circuits. Some are more complex than others, but they all have these 4 things: resistors, transistors, capacitors, and switches in common, and they're all connected, or the current all flows around them with wires or traces. So you'll be able to see, even though they're a bit different, this one's a bit blurry, you can see all these little pathways going everywhere around them. If you can't see really on the microbit, these are the ones we'll be using, by the way, guys. There are all these little pathways going all between the little bits. This green one here is the easiest to see. So all these things are connected and they're all interrelated. So the second part of the success criteria that you needed to understand was how they were all related. So first off, we need to work out which bit does what. So like I said, electricity flows around a circuit board in a current. Sometimes I might want to reduce that current. So the electricity flows on the path, like I've said, wires or traces. While it's going through on that path, you might want to reduce it. So you might want to reduce the flow of the current. That's what resistors are used for. If you want to increase the flow of that electronic current, you use a transistor. So resistors to reduce, transistors to increase. Sometimes I might want to hold the current and store it for a bit. Yeah, that's what a capacitor is used for. And finally, last but not least, I might want to just stop it like a gate, stop it and then open, then close, open, then close, open and close, and essentially control when and where that electronic current flows. I use a switch. So I can increase the current, I can reduce the current, I can increase the current, I can hold it, I can, stop it with a gate, and as it goes around on a path. And they are the 5 things, guys, or the 5 different components of an electronic circuit board, and that's how they're related.